All right, good day, everyone. We're going to be talking about lesson 7-1, analyzing a quadratic function. Kind of going along with everything we've talked about so far with understanding kind of what a quadratic function looks like, how to actually apply things like it, how to actually work with it. And really take it to the next level to really understand a situation where a quadratic function would actually be used and analyzed within the graph itself, okay? Now, in this particular problem, they basically have this situation where you have 100 feet of fencing and you want to enclose a large area, okay? So basically what you're trying to do is create a fenced-in area like so with 100 total feet of actual fencing material, okay? So here's kind of the first thing I want you to think about. This is really just a rectangle, where, let me draw 0, but you have a length on each side, and you have a width, okay? Where the two widths are going to be the same exact value. Okay, I can't have different side lengths. And my two lengths are going to be the same exact value, right? So basically what I want to do is try to understand how much feet could I use and what would maximize my area? How can I get the largest amount of area? Well, to understand this, I want to understand two different things. First off, area equals length times width. And then the perimeter, which is the total amount of enclosing, which is the total amount of enclosing I can go around this fencing, is going to be 2 length times 2 width, okay? Which makes sense. Basically, this is saying that if I have 100 perimeter, then 2 times the length and 2 times the width should add up. Well, that's exactly what this rectangle over here is saying. If I add up 2 widths and 2 lengths, that should be 100, okay? So the idea of this that I really want to try to think about is if the width of the rectangle enclosure is 20 feet, what must be the length of the rectangle, okay? Well, one of the things you want to think about is this width and this length added together have to equal half of that, okay? So that's basically telling me for number one, 50, which is half of 100, has to equal length plus width. Well, if they're telling you that the actual width of the rectangle is 20, well, that tells me that the length has to equal 30 then, okay? Because 20 plus 30 has to equal to 50. So what they want us to do is basically play around with some scenarios. Well, I want to kind of go through this idea where, let's just say I had like a width of 5, I would have to have a length of 50. If I had a width of 10, I'd have to have a length of 40. And I can pretty much continue this process over and over and over again. 15, I'd have to have a length of 35. 20, length of 30. 25, length of 30, or excuse me, 25 as well. Then eventually our width becomes bigger and our length becomes smaller. So if I have a 30 width, I need a 20 length. 35 width would be a 15 length. And then a 40 width would be a 10 length, right? So at this point, what we're going to do is actually start solving out for the area. Well, the idea for area is just length times width. So really, I just have to multiply these two numbers together to get the total area. 5 times 45 comes out to be 225. 10 times 40 is 400. 15 times 35 is 525. 20 times 30 is 600. 25 times 25 is 625, I believe. Let me double check though. Yep. 625. And then you almost start to repeat yourself. 30 times 20 is 600. 35 times 15 is 525. And 40 times 10 is 400. So you kind of see how we go up until this point here. We're increasing in that whole interval. And then all of a sudden, below that blue line, we start to decrease. Well, that should kind of tell us that this graph is going to look similar to this, okay, where I'm going up, 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 and then eventually I come down on that value, okay? So I know this has to be a quadratic function just based off the numbers, everything like that. But I want to know what's the biggest possibility I can get. Okay. So what I want to eventually do is I want to try to develop an equation. I want to try to think of like, how can I turn this into an actual equation itself? Now, what we're going to do is derive this, but after we derive it, you have an equation for yourself to use in any one of these problems. Okay. So here's what I want to think about. Okay. Basically, I want to try to derive out an equation. And to do that, I'm going to need the two other equations I had on the other page. Area equals length times width. Perimeter equals 2 times the length plus 2 times the width. Well, here's what I want to do. Let's go ahead and try to work this out so I actually get myself an equation. Basically, I want to try to get area in terms of just the length. Okay? So I need to somehow cancel out that W. Well, to cancel out the W, I need to plug something in to replace it. Well, that's where this stuff comes in. Okay? Let's go ahead and use this equation to our advantage. We know the perimeter is 100. And then since they both have a 2 in it, let's factor out a 2 to get that equation. 100, which was the perimeter on the other page, equals 2 times the length plus the width. At that point, I can divide out the 2 to get 50 equals length plus width. And then if I want to replace the W, I just need to move the L to the other side. This would become W equals 50 minus the length. Well, if you notice, now that I have this equation where W equals it, I can come back up to the beginning and grab myself or plug this into the original equation to get the area equals length times 50 minus the length. And if I distribute the length through, notice what I get. This would become negative L squared plus 50L, which in essence is a quadratic equation. Okay? And so a lot of these problems are what they're going to have you do is derive the actual value from this. And here's kind of the key thing for you to understand. Okay? When I want to derive this problem out, when I actually want to work this out, I really can just use the equation. The area is going to equal length times the perimeter divided by 2 minus the length. Okay? And by using this equation, all I need to really find is that value of P. Okay, this value in red here, this red P is the only number I'm going to need. So they tell me I have an area of fencing of like 500. All I would have to do to solve this out is just plug in length times 500 divided by 2 minus the length. And I have my equation. Okay? And so we can use this equation to our advantage, and we'll talk about this on the review day for us and how we can use that equation to help us solve a lot of these problems out. Okay? But that's the idea of the lesson, how we can take a real-world situation and turn it into an actual specific equation. We'll go over this tomorrow in class. Besides that, if you have any questions, bring them in class tomorrow, and we have a great day.